Hello everyone, I'm Krati Gupta, Assistant Professor from Kite Group of Institution. In this video, we will be studying about the next searching technique, binary search. The content for binary search will be, we will be studying what is binary search, what is the basic concept of binary search, what is the implementation of binary search algorithm, analysis of binary search, and the next index based sequential search technique. Only the introduction part we will be covering in this video. Next, we will be covering in upcoming lectures. So the first topic, binary search. So binary search as compared to the linear search is one of the fastest searching algorithm. It is used to find the location of an element in a linear array. The basic principle for binary search is divide and conquer technique, and the restriction in binary search is that this binary search algorithm can only be applied on the sorted arrays. That is, if your array is sorted, then only we can apply the binary search algorithm. And if you need to implement the binary search algorithm in an unsorted array, then in that case, you first need to sort the array by using any of the sorting techniques. We have multiple sorting techniques like bubble sort, selection, insertion, heap, quick, merge. We can use any of the sorting technique, and by that sorting technique, first we will sort the unsorted array, and then we are going to implement the binary search algorithm. So the basic divide and conquer approach is that first what we do, we divide, we decompose our problem statement into a smaller problem statement, and we solve our big problem statement, the original problem statement, by solving these smaller problem statement. Okay, so the problem is of searching an element in an sorted array. We have taken the sorted array. So what we are doing is the concept of divide and conquer in this particular problem is we are comparing the element x, the element which is to be searched in a linear array. We are comparing this x with the middle element of the array. If the match is found, if the element to be searched is matched with the middle element, then in that case we return the mid index value. As the element are found, as the elements were compared and the element are found, then what we are doing, we are returning the position where the match was, where the comparison was correct, successful search was there, so we have written the middle index value. But if the match is not found, if the element does not match with the middle element, then what we are doing is we are comparing whether the element to be searched is greater than the middle element or less than the middle element. If the element x is greater than the middle element, that means that element x can lie only in the right sub half of the array. As x is greater than mid element, and all the element greater than mid are present in the right side of the array, because array is the sorted one. So what we are doing, we are again using this binary search concept in the, now we have divided the array in the half part. Middle we already compared. Now the lower part will be updated and it will be mid plus 1. Now we will be comparing in this half part. And if the element is less than middle element, then what we are doing, then that means the element must be present in the left sub half of the array. So now we will update the higher index value. It must be present in the left half, so we will update the higher index value, and we will be doing it with updating it with mid minus 1. Let's take an example and understand the concept. Suppose this is our array which I have the indexing from 0 to 9, and the element to be searched is 23. So the lower bound is 0 and upper bound is 9. So first we will find the middle index of this particular array. Middle will be lower plus upper by 2. 0 plus 9 by 2, it will be 4.5. We are taking the lower bound, so we are taking the fourth. So the middle index value is 4 and the element present in middle index value is 16. First comparison is done with 23 and this 16. Now we have compared 23 is not equals to 16. So next we will be comparing whether 23 is greater than 16 or less than 16. Now 23 is greater than 16. It means that it must be present in this right sub part of the array. Why? Because all the element in the left are smaller than 16 and 23 is greater than 16. So now we are updating, as we have compared already, we have compared with the middle value. So we will be updating the lower bound as lower bound equals to mid plus 1. So now the size of array is reduced to half. Now we only need to make a search in this half array. Okay. Now we do not need to check with the lower half. We will be comparing it only with the right half. right side. Now again, lower bound is 5, upper bound is 9. We have find the middle value 5 plus 9 by 2. It is what? 5 plus 9, 14. 14 by 2, 7. So 7 is the middle index value. Now, 7 is the middle index value and the data present in 7 is 56. We have compared 23 with 56. It does not match. Now we are comparing whether 23 is greater than 56. No, it is not greater than. It is less than 56. Then it means it must be present in this right, left sub part of the array. Array is starting with lower bound 5 and it must be on the left side of this middle index. So we will be updating the upper bound as mid minus 1. Now lower bound is 5, upper bound is 6. We need to compare the element. We need to find the element, search the element 23 in this particular half of the array. Now again we find the middle index location. Lower bound is 5, upper bound is 6, 5 plus 6, 11, 11 by 2, 5.5. We will be taking lower bound 5. Now we are comparing again 23 with this middle index value, that is 5. 23 matches with 23. That means our search is successful and element is found at index location, middle index location, that is 5. So our search will terminate and search, it will be printed that search is successful, element is found at location 5. Okay, suppose our element was 24. If that was the case, then 24 does not match with 23. Now again we have shifted the lower bound with plus 1, that is L will be equals to 6 because 24 is greater than 23. It must be present in the right side. Now L equals to 6, H equals to 6, middle will be 6. Now again search is not found. Now as 24 is less than 38, then it will be shifted, upper bound will be shifted mid minus 1, then upper bound will be 5 and lower bound will be 6. This will result to the error does not exist case. Okay, so with this binary search, uh, what we can do in this binary search, we can also find whether the element whether the array exists, element exists in the array or not. Let's talk about the function. Suppose this is an array where element are needed to be searched. The lower bound of array is L, upper bound of array is R, and the integer element to be searched is an element X. Okay, so search is only possible if array is existing. And how we can check whether the array exists or not, whether the elements in the array are present or not, if and only if the upper index location is greater than or equal to lower index location. Equal to case comes when array contain only a single element. Then the single element, in that case, lower bound and upper bound will be equal. Otherwise, upper bound will always be equal to the lower bound. So if the elements are present in the array, then upper bound will always be greater than or equal to the lower bound. We will be finding the middle index location. Middle index location is lower bound plus upper bound by 2. Then we will be comparing it with the element to be searched. If the match is made, we will return the mid index location. If the match is not made, then next we will be checking whether the element X is less than or greater than, whether the element X is less than middle index location. If it is less than middle index location, then we need to update the upper bound. Array will be same, lower bound will be same, upper bound we have updated with mid minus 1, and element X is to be searched in this new array, which is starting with this lower bound and ending with this upper bound. And if the element X is greater than middle index location, then in that case we need to update the lower bound. Lower bound will be mid plus 1. Why we are not taking mid? Because we have already compared with the middle index location and it does not match. That's why we are taking mid minus 1, or lower bound will be updating with mid plus 1. Upper bound will be same, element search will be same. And suppose the element was not present in the array, then in that case all these conditions will be false. Then we will be returning minus 1. This minus 1 will be signifying that element was not present in the array. So this is the concept of binary search. Next we will be talking about the analysis part. And in analysis, best case is when the element is found at only single comparison. That can be done when the element was present in the middle index location, and at the first comparison only we were successful. So in only one comparison case, time complexity will be constant. For the worst case is when the element was not present in the array. So in each iteration, what we are doing, our search get reduced to half of the size of array. So suppose the array was of n elements, so total number of recursive call that were needed, or total number of iteration that were needed, were be each time size of the array is reducing by half, 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 half. So total number of iterative call will be log n base 2. So total time complexity for binary search will be log n base 2, where n is the number of elements in a sorted array. Next searching technique is index sequential searching technique. It is also one of the another improving efficiency improving technique, and this technique is also applied in a sorted list only. But this index sequential searching technique is applied uh, when we are using the large number of data is present, that is in the database management system. Okay, where we have stored a large record, and we need to search a record among these records. Okay, so over there we are using the index sequential searching technique. What we are doing is, apart from this sorted list of element, we are also making the index set of this sorted list. Okay, now we can make only single index set, or we can make a multiple index set, that depends on the data amount of data that was being stored. And now in this case, what we are doing is, each element in the index point to a block of element in the array, or another expanded index. First we search the element in the index file, and with the help of this index file, we are searching in the main array. Okay, let's take an example. Suppose this is our data is stored in this sorted file. Okay, now what we have done, we have made certain index files. First search will be done in the highest index file, that is secondary index file. With this the help of the pointers in this secondary index file, we will be guided by the primary index file, and then with the help of the pointers we will be guided towards this main sorted file array. Okay, suppose the element which is to be searched is 480. Then from the secondary index file we have checked for 591. 480 is less than 591, so it must be present before 591. Now it is less than 321, greater than 321, and less than 485, so it must be present among these index files. So with the help of primary index file, we do not need to make a search in this part. We are only making the search in certain part, that is between 321 to 485, to find 480. Okay, this index sequential search can be applied with the help of B tree or B plus tree, which we will be studying in our further lectures. So we will be covering it later. Um, in this session, we will be only talking about the index linear and binary search. Index sequential search will be covered in B tree and B plus tree in unit 5. Thank you.